Hello world, good morning, good afternoon, good evening. Welcome to CodingScientist.com. We are learning about artificial intelligence and robotics using Jetson Nano and NVIDIA's JetBot module. Guys, let's take a look at it where we have reached. Let's look at our manual and we are at lesson number 31. So we are going to look at how the collision avoidance AI model works in JetBot. This is a pretty intensive lesson, guys. So let me give you a heads up. You got to be really patient in this particular lesson because there are ton loads of things and probably it might extend for a couple of you might have to spend couple of hours to understand in detail. So let me give you a pretty high level view about collision avoidance artificial intelligence model which is going to be working in JetBot. So let me go to the browser and let me log into my Jetson NVIDIA Jetson JetBot. HTTP colon slash slash, what was my IP address? It was 192. Okay, there you go. 192.168.1.17. So your IP address might be different, so keep a note of it. I'm trying to log in. For some reason it shouldn't be taking so much time. I'm wondering what's happening. Looks like my internet is down or something. It seems to be connected well. Let me try to reconnect again. There you go. Guys, if your internet is slow, this program might take a lot of time because I'll tell you the reason why. So what you need to do, go to the main directory here by clicking this box, top box, and then double click on JetBot. Go to notebooks and then double click on collision avoidance. In collision avoidance, the first thing we are going to do for this matter any artificial intelligence application, the most important aspect is collecting data, right? Without data there is no AI, so keep this in mind. For the folks who are totally new to AI and Python coding, I would highly recommend go through my Python classes, Python tutorials, and pretty high level information on the AI stuff as well. That's a different series. So go through that and come back to this lesson. All right. So here I'm not going to talk in detail about breaking down the codes into multiple sets and stuff like that, but I'll give you an idea how to go about it. So the first thing is we need to collect data. So you need to open the first one, that is data underscore collection.ipynb. Double click on that and we have pretty much self explanation here, right? So you can go through that, then highlight the first line of code and then run through. All right, I am not going to run through this code because I have already trained my JetBot and collected some data already. So this is a pretty intensive task, guys. You need a lot of patience and you got to run this one by one. So highlight this, click on this, and then you need to go to the next one, that is import OS and create. So let me tell you something, guys. So as soon as you run this first code, first line, give it a minute. Give it for wait for at least about 60 seconds, right, for between each cell. This is the cell number 1 and then cell number 2. Once you write this code, once you execute this particular code after clicking this button, wait for a few seconds and you can see a folder automatically popping up here. On the left side you can see a dataset, right? A folder called dataset. It's called a directory, right? Inside the directory, if you double click, there is 2 more subdirectory called blocked and free. Okay, so I'll talk about that later. So go ahead and run this code and wait for a few minutes. You will automatically see this dataset directory populating up, and then go to the next set of code again follow the same thing, click run, and then you go to the next set of code from UUID, import UUID. I'll explain you at a later stage, but there is a self-explanation in jetbot.org site. So run the highlight again, or you can just control A and click this button. Okay, I'm not executing this code. As I said, I have already trained the model and kept it ready for you guys to see. All right, and then what you need to do, display the image. You will probably, let me just run this and show it to you guys. Maybe you'll get an idea about what we are talking about. There is nothing wrong in running this code again. Let me just run this. All right, now the camera is open. You can see the camera. My JetBot is facing behind me. I'll talk about this red ribbon very quick in a couple of minutes, and then highlight this code, run this again. Okay, here it says directory not created because they already exist. I have the directory here. Can you see that? This is the reason I was not trying to run the code. But never mind. I will go ahead and run the next line of code. If I run this, you will get two different blocks here, add block and add free. So what basically this means is you are going to take pictures from your JetBot in different angles. Okay, so you need to take the picture in such a way that I'm going to talk about that in a while. Just give me a minute. Then what you need to do, you need to run the next line of code. Once you run control A, let me just control A to select the entire set of code, run this. All right, once you run this, go back down, you will see you need to create the widget box again by running this code, display image. There you go, you got the same widget again with the camera here, right? Now I will show you what we need to do. Let me switch over to my secondary camera and I will show you what exactly has to be done. So I have a table here. I have a small table in my lab where I put this red ribbon, just to create a kind of block, so you can use a red tape or a red ribbon in a table, or maybe on the floor as well. And what you need to do, take your JetBot, okay, take it in all the directions. You take a picture wherever you are close to this ribbon, keep the camera very close to the ribbon, okay, the red ribbon. And then what you need to do, let me just share the screen again. And then what you need to do is, once you go to the block section, that is the red color ribbon, you need to click add block. As soon as you click add block, that means the bot is going to click one picture of the blocked image. That means in the neural network, when the bot is moving, the camera is going to detect that red color ribbon stating that, hey, it's a block, so do not override it, take a left. That's what it is. So click like that. And then what you need to do, let me share this again so that you guys can understand very clear. Similar way on each block, say for example this entire line, the entire red line, right? You can keep moving your bot physically with your hand. You need to keep changing the positions. So you keep changing the position and keep clicking block, 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 like that, right? So go all over the place. At least you need to take about 100 different pictures. Make a note of it, guys. You need to, this is a very important point. This is a very important point. You need to take about 100 different picture of block and 100 different picture of free. Okay, it's very important, because more the amount of data you have, and meaningful data, not just click random images. It has to be that image should have some kind of meaning. So that's the reason, take the bot closer to the blocked images. That is your red line, okay, red ribbon. Keep shifting the position and keep clicking the images. You need to have at least 100 different images of blocked. And then for free, what you need to do, let me just show you. for free images here, add free. So what you need to do, let me just share the bot again. So what you got to be doing in the free images, shift the bot like this, where you can see the space is empty where the bot is going to move. Of course, that because of the camera, because of the Raspberry Pi camera, it's going to cover the red line as well. But the majority of the position is white, right? So the bot can move freely without any blockage. So you keep this in this position, keep the JetBot in this particular position, wherever there's a free space to move, and then keep taking picture in each position like this, like this, like this, like this, like this, and then you can turn it, take a picture again, and then turn, take a picture again, take a turn, picture again, take a turn, picture again, and picture again, picture again, picture again, picture again, click free, click free, click free, click free, click free, like that. So I hope this is clear, guys. So this is how you are going to collect at least 100 images of free and 100 images of block. It's a tedious thing. It's going to take at least, probably about an hour or so. Again, it depends upon the speed of your internet, how quick you can take. But let me also show you a very important thing, okay? Let me just go to the browser. All right. So once you're connected to JetBot, once you click add block, right? So this takes few seconds to populate as one. Okay, this takes few seconds. You should not keep shifting your robot left and right with your hand and keep clicking this add block or add free, add block or add free randomly, right? Do not do that. So you got to give it few seconds till you see the number 1 populating, then you see the number 2 populating, then you see the number 3 populating in both blocked and free. So this has to be done very slowly. All right, guys. So it's a very important thing. Okay. Now the last point in this particular data collection lesson, after you click at least 100 images in this position, right? You can what you need to do, come to the bottom, do not stop the camera, okay, for now. Though it is mentioned, let's close the camera connection properly. Maybe you can stop, it doesn't harm, but you can just go ahead and stop it. But however, just for my trial, I did not stop it. I just left this page open and went into the next code. So you can stop it, it's not a problem. But most important thing is, do not run this code, zip space -r space q. Do not run this code at all. This is basically what it's going to do is, you are going to zip this entire data set what you collected. You would have collected about 100 different images for blocked position and 100 different images for free positions, right? That's basically called the classification. So do not zip it. Zipping is required only when you are going to export this data into a different GPU or a different laptop machine where you want to train it and redeploy it again. That's a pretty complex procedure, which is going to be a different lesson altogether I'm going to cover in the future. For now, to operate just the JetBot collision avoidance, do not run this, guys. I'm insisting again, do not run this code, because I have done a lot of R&D. It's a kind of, it just messes up your JetBot OS sitting on your JetBot. So do not run this code. Just leave it as it is. And then what you need to do, you have to just close this, okay? Once you close this browser, now again watch carefully, go to the bottom. Just by closing the browser, just for that particular program within the browser, within your notebook, is not going to help. You need to go to the bottom here, the $sign. Okay, click on that. You can see there are 2 programs running. Both you can close it. Click shutdown, and then click shutdown. Okay, and then go to this box again on the top, the directory, the main directory. Okay, now the data collection has been done. Now what we need to do, we need to train the data. Okay, we need to train the data to make your neural network work, right? So your JetBot has to understand where the free space is, so it's going to move towards the free space. Wherever there is a block, it will just stop and turn, right? So that's what we are trying to build. So NVIDIA has a beautifully pre-trained neural network called ResNet 18. So that's what we are going to use. We don't have to build the neural network from the scratch. We have a pre-trained neural network in which we are going to load our data sets, that is the images which we captured in the data collection .ipynb, and deploy and train that using the RESTnet. So click this one, train underscore model RESTnet 18.ipynb. Just double click this. All right. Once you double click this, again the same thing. First set of code you got to run it. Control A and click run. All right. Once you do that, let me just run it again. Okay. Wait for a few seconds and then go to the next one. Unzip. Do not run this, because we remember in the data collection we never zipped the data. So do not run this code. It's going to cause some other issue. Do not run this code. Move directly to create data instance. This is where we are going to create an instance and load the data sets, okay, which you collected. So where there are certain filtration criteria and stuff like that, but do not worry about that. You will understand as we go along. Click this. All right, and then move on to the next one. Split the data sets into training set. Of course, the 80% of the set, the data is going to run into your algorithm, into your neural network, but 20% of the data, both blocked and the free images which we collected into the directory, is going to be used for the training purpose. So run this particular code, highlight it, click run. All right, now we need to load the data in different batches, right? So batch size of 8 and another batch size of 8. So highlight this, run this program, and now we got to, once you run this, wait for a couple of minutes, at least 1-2 minutes, let it run, and then define the neural network. All right, we are going to define the ResNet 18 pre-trained neural network. That's why it says model.ResNet 18 pre-trained equal to true. We are going to train this model. Click this. All right, and then we are going to set some weights for the classes, right, which we already have. Now click this. All right, move on to the next code. Finally, we transfer our model to the GPU, that is our Jetson Nano GPU. It's basically a transfer learning toolkit, guys. That's the method we are applying here. We are going to use the ResNet 18 neural network, pre-trained neural network, load our data, train that, and deploy into our CUDA, into our Jetson Nano GPU. So click this. Let it run for a few seconds, wait for a few seconds. All right. And then as soon as it is done, go to the next one. Now, this is where you are going to, once you run this, you will see a file here called best underscore model underscore ResNet 18.path, PTH. So this file will automatically populate in your system. For me, it was already there because I have done this a couple of times before, right? So you can see this file populating. Do not open that, just leave it as it is. Okay. Now we are going to train the neural network. This is the next section. Epoch is one iteration of running the entire set of code. So we are going to run 30 epochs. That means 30 times, 0 to 29 times your entire data has to run through and get trained into the neural network. All the inputs and the outputs and the middle layers need to get trained till you get the final output. So this is what we are going to do, which is going to take a couple of minutes time. Let me highlight this. Before doing that, I would say right click, just keep your mouse here, right click and create view, new view for output. Okay, how did I go there? Keep your mouse here, right click, create new view for output. If you do that, you can see there is an output window open. For me, it already shows 0 to 29 because I had already trained my network, but I'm going to train this again. There's nothing wrong. I'm going to just probably minimize this little below and then Control A to select this code and click run here on the top. Once I do that, all right, now the best model underscore ResNet 18.p, you will get this particular batch file showing as best model output. Okay, so once you get that, now what we need to do, right, now see here, can you see a number is populating 1 0 1 2. So like this, now the neural network is getting trained with the data set which we already collected here in this particular directory, which is the data set. So here you can say 0 to 6, now it's going to go to 7, then 8, like that it will reach 29. That is 0 to 29 is nothing but 30 epochs of data sets being trained into the ResNet 18 neural network. So guys, you are working on artificial intelligence, you are working on the neural network, so it's pretty interesting. The good part is NVIDIA JetBot and this particular training platform has made it so easy for us to understand how end-to-end AI works, especially when it comes to the computer vision part, capturing the images and process it into the neural network and make the robot to understand where to move, where not to move. So basically we are building a self-driving car, right? All right, let's take a look at it. 23, I have reached 23, 24. Let it go through this again. 27, 2 more to go, 28. $29. All right, now the training has been done in this. All right, you can close this. All right, now we can close this. So your training, the model training has been done. Save it. All right, then what you need to do, go to this $sign and shut down. Once you shut down, go back to the main directory here. Now we need to deploy the trained model using ResNet 18. We need to deploy that in our live demo. That means we are going to deploy that in the JetBot sitting just right behind me. So we are going to deploy that into the brain of Jetson Nano so that it can start functioning. So how do we do that? We need to go to live demo, live_demo_ ResNet 18.ipynby. Just double click on this. All right. Now live demo, what we need to do, load the trained model. So we have this best_model_ResNet, right, which has been created. That is the best model output we got. Okay guys, before we do that, you need to keep retraining this model again and again to get 100% accuracy, right? If you want your bot to perfectly, keep turning, avoiding the objects and the blockages and follow certain direction whichever way you want, you need to retrain your data a couple of times at least. So keep that in mind. Now what we need to do, we need to import torch vision. Okay, I'm running, and now what we need to do, we need to attach our trained model data set. I'm attaching that. Wait for few seconds, be patient till the star mark should go out. It should show the serial number 2 or the sector number 2. There you go. Now you can see all keys matched successfully, which is a good news. All right, now let's go. Next one, we need to deploy this into our GPU device. Currently it has been trained on the CPU. Now we are going to deploy that into your CUDA, that is your Jetson Nano CUDA GPU. Let me run this code. Alright, wait for a few seconds and then go on to the next one, where we are creating a pre-processing function that is basically assigning the weights and stuff like that, which is going to come, and we are also going to realign the images captured from the camera, from the JetBot camera, versus the data sets which you already have, which we trained at. So it has to keep matching, so we got to realign the pictures and the formats here. So that is what is going to happen in this particular code using torch vision. Let me run this code. Now we have defined the pre-processing. So let's, by converting the images and stuff like that, now let's go and try to open the camera by using this widgets. All right, let's run this. There you go, the camera is open again. Now you can see there are two grids, speed versus there is another grid called blocked and free at the bottom. So what you need to do, drag the speed to at least probably till here, right? If you keep it in the lowest position, your bot is not going to move. Okay, initially I was wondering why the hell bot is not moving. Then after doing some R&D, I figured out, oh my god, I need to increase the speed. So just slightly, don't increase to the max. It's going to run very fast and hit and bang. Keep it to the minimum, maybe at point 13, or maybe, yeah, I think point 13 is fine. Maybe point 13, yeah. Now we will create the robot instance which we had done in the first lesson. So we are going to recreate that again from JetBot. We will import that particular instance, right? So highlight this. Now at this moment, no, I think the next section the bot is going to run. Click this. All right. Now I am going to run the bot. Okay. Since my JetBot is not trained fully, and I'm still yet to do multiple iterations of training for the bot to understand the images and the blocked versus the free space. So it might randomly run here and there, but anyways, I'm going to run this. And before I run, I will just shift the camera and show you towards the JetBot what is happening. All right, I'm just shifting my camera. The JetBot is here, right here behind me. Now let me run. I'll just hold it in my hand so that it doesn't skip away. I'm going to run this particular code. It's taking some time. There you go, it's moving. Can you see, guys? The bot is moving now. It takes a while, but it takes time to do the detection part as well, because it has to go through multiple iterations of training. Okay, I think it is detecting. I can see the detection has been happening, but it's not that perfect. It has to really move left and right. So probably we need more data points here. Alright, I need to switch off this. Let me just check how to switch it off. Okay, camera link, camera stop. Okay, to stop this, I need to go through the next set of code. That is where we will stop. I'm just holding the bot in my hand so that it doesn't fall off, right? Alright guys, looks like this model is working perfect, but we need to train this model again and again. Now I am going to run this particular section of code to stop the bot. I hope it stops. Value error. Okay, what is that error? Trace back most recent. Yeah, X value, X not in the list. I think it's too much towards the blocks. So guys, you got to play around with this parameter, blocked versus free space and the speed and stuff like that. So that's where you are going to gain some expertise and make it work as desired. So you can debug this. If you are getting this error, it's pretty easy to debug, find out what exactly is the error. We can stop the camera, we can stop the bot, and do tons of other things. Alright guys, this is the end of this lesson. I hope you enjoyed. The collision avoidance is perfectly working. Now it all depends upon how well the data is getting trained, right? So most important thing I want to just highlight here. For example, if you go to, let me just go to the browser, let me show you something. If you take a look at the data set, say for example blocked here, I hardly have about what 15 pictures, which is not sufficient, right? And if I go to free, that's another 15 pics, which is not sufficient, guys. We need at least 100 pictures, 100 different pictures. That's very, very important. Unless until you have minimum of 100 blocked and 100 free, and get that trained and trained and trained again, that's where your entire full end-to-end neural network between input and the output and the hidden layers in between is going to fully connected. It's going to be fully connected and it's going to be perfect, and then your JetBot is going to absolutely detect all the objects and the paths and kind of thing, and it's going to move autonomously like a self-driving car. Alright guys, I hope you enjoyed this particular lesson, and I am going to get back to you soon with the next video, and it's going to really get interesting. Goodbye until then.